The broadcast is now starting. All attendees are in listen-only mode.
Welcome everybody to another BobCAD-CAM live event. My name's Andrew. I'm going to be the host today. We're going to be taking a look at the 3-axis Pro versus Premium here. We're going to get started about 10 minutes or so. There's a bunch of people that signed up today. It looks like not even half of you guys are in here yet. So we'll get started shortly and then we'll get going. All right, welcome everybody that's joined in the last 5 minutes. We're just giving a couple minutes for people to join in. We'll get started here in about 5 minutes. All right, again, welcome everybody to another BobCAD-CAM live event. My name's Andrew, and we're going to be taking a look at the 3-axis Pro versus Premium a little bit today. So let's go ahead and get started here. Just going to drag a file over into my workspace. Now this already has a roughing on it. We've kind of gone over the rest roughing and roughing quite a bit. So we're just going to kind of jump into some of the finishes. Now when you're looking at 3-axis, you're going to have a couple of different options. So you have your 3-axis wizard, which is going to have your wire mesh toolpaths. So these typically you're going to select the entire model, but just for today, just for this example, I'm going to pick a single surface because we're also going to look at the comparison of the premium toolpaths for some of this. So I'll click select geometry, and I'm just going to work with this floor right there. All right, so my top of features already listed, my workspace is at the bottom. And we're just going to start out with the advanced planer. Now, for anybody that's used the advanced planer, you know this is just a single direction toolpath. So when you're cutting something like this that has a nice organic floor to it, you can run into some links and a little trouble with getting it to work right. But we're going to take a look at the difference between them. So we're not going to do anything on our posting page or the multi-axis posting page. I'm happen to use one of the new Haas UMC 500 Super Speed series machines that we have built. And I'm just going to go in with an 1/8 inch ball. Now, if you are using a multi-axis machine and you have the auto 3+2 kind of stuff, you'll have this page. Most of you probably won't, so I'm just going to hit next. And like I said, planer is a step over calculation. It does floors really well, but it is one direction, back and forth or just a single side. I'm going to do a zigzag to go back and forth, and I'm going to play around with my lace angle. So first, I'm going to leave the lace angle at 90 so we can see how this applies to it. And we'll start in the lower left. Now I'm going to go with the 30th step over, just so we can see what we're looking at today. And I'm going to try to keep that pretty consistent through all the toolpaths. Not too worried about a lead in. That's really not what today is about. Our options, we're not using a boundary or anything. We don't need anything for links, gouge check, advanced feed rate, or the MDI. So I'll just go ahead and hit compute. Now you'll notice that that's just going back and forth down this channel. Now it does a good job. It's going to be well enough to finish it. Let's go ahead and just show the simulation for this. Now the roughing, I'll just kind of speed through that a little bit. We'll skip over it. And I'll slow this down just a little, and we'll run our planer. So this is just running back and forth. I probably could go with a little larger tool. Which, if you are in version 35 and you do want to change the tool, let's go ahead and do that. I'm going to go ahead and stop the simulation. And I have my operations window over on the other side of my screen. For most of you, if you have 35, it's going to be on the left-hand side. You can dock that on the right-hand side like I do, if you'd like it better over there. And I'm just going to look at my tool tree real quick. And I'm going to take the 1/8, and I'm going to replace that. And I'll hit yes, I want to replace it for all these features. Now let's just say I do a 3/16 ball. Let's actually just add a new one. And if you're not aware, you can do the division in any field in BobCAD, any field except for the multi-axis toolpaths. Those you can't do math in. But if you're just trying to find the radius and you don't know what it is, you can divide the diameter in half. So we're just going to go with that tool, not even worried about the label. And you'll notice now in my feature tree and my cam tree, that feature is flagged. So I'm just going to recompute that, and I can compute it from either way. I can go over to my operations and do it, or I can come over to my feature and do it. But now, the cool new thing in 35, I could just hit start simulation. And even though I have it already open, it just reloads it. Oh, interesting. It went small. All right, let's close that. Never seen it do that. It starts out small, typically if you have it as the undocked. Now I have mine docked within BobCAD, so I'm not sure why it stayed that way. I'll just go ahead and jump to the planer. And this is just going back and forth throughout this channel. So if you're trying to maintain as much with as least amount of links, this is probably going to be a little difficult to find the right angle. This angle works pretty well at doing this. You know, looking at the toolpath, it doesn't look like it's going to link a lot. But it's not going to be really smooth with the contour of this shape. So if I want to try to follow that a little bit, I'm going to have to play around with my lace angle. Now, if anybody's new to doing any of the live events, there is a questions field within the GoToMeeting panel. You can ask any questions you'd like. We are going to have a little bit of time reserved at the end for Q&A. We're going to go through the content that we have kind of set aside, and we'll kind of field any questions from there. Since there's quite a few of in here, I hope to hear from a lot of you. So that did the floor just fine, but it's really not following the contour of this shape. Excuse me. So if I want to try to do that, the planer can be modified a little bit by this lace angle. So if I start playing with this angle, like if I say 45 degrees, now it's going a little longer. And as it goes down this channel, it's kind of going back and forth. So this actually kind of follows it a little bit more, but it's really not following that shape. It's going to go across that shape. And then you can spend quite a bit of time playing around with this angle. And I think I actually eventually went to 135 degrees before it had a decent flow with this channel here, but you can see it's retracting quite a bit. And if anybody's not aware, in the simulation, under the move list, you can click on the operation you want to see, and it does everything up to there, which is how I'm skipping the roughing. And now we can see where it's starting to retract, but now it can get a little bit longer down that channel, but it's still not going to be really flowy and consistent. And we'll see what the simulation looks like at the end here. So it did kind of the same job, but the cusps are a little bit different. They're a little bit wider apart because of the way that it went down the channel in certain areas. Still not great. You'd probably need to do a bunch of extra work to get that really smooth. So let's start taking a look at what it would be for the multi-axis, or the surface-based toolpaths. So we're going to blank this one out, and I'm actually going to disable it since we've already kind of seen it in simulation. And if any of you are not aware, you can do that right from these two bars here. You can move them from either side of this CAM tree. That's actually up in your settings. So under settings and CAM, you now have all the new look and feel options for your CAM tree. You can even go back to classic if you prefer. All right, so I'm going to right-click Machine Setup 1. We're going to go down to Mill Multi-Axis. And we're looking at the premium, so that's the surface-based toolpaths. So I'm going to be using Morph Between Two Curves. This is kind of one of my go-tos for a lot of stuff. This can be used in a lot of different ways. And I'm going to use that same tool. So I'll hit Next, and I'm going to leave the same 30,000 step over. But with these, the geometry selection is a little different because these are surface-based toolpaths. you're picking the surface and the edge to follow. So I'll pick my first and second edge off the model. And then my drive surface is what I want to cut. Now that I have those selected, the only thing I'm going to do is change my maximum step over. And it does say maximum there, and there's a good reason for that. And I'm also going to change my output to 3-axis. And we'll hit compute. Now it is crashing through the model here. We'll adjust the rapid retract. But now we can see that toolpath is just flowing right along that surface. It follows exactly the curvature. And it goes down as narrow as it can, maintaining the same amount of steps at beginning and end. So you're not getting a lot of retracts between the whole thing. So let's actually change this. Let me make it zigzag. So we'll change our cutting method to zigzag here. And I'll hit compute again. That way there's no retract to have to worry about. And we'll start simulation again. Now because I have the planer disabled, it will not be in the simulation at all. So we'll go ahead and skip the advanced rough. Now we'll run this simulation. So you can see this is just automatically going to follow that channel and all the curves to it. Now, the simulation does run at a lower resolution, so as you're watching it, it's not going to look very good, but when it's done or you pause it, so if I hit pause here, it's actually going to refine that a little bit. Speed it up just a little bit. Now, this toolpath does have the option for an exact step over if you need it, but it's really made to morph between the two sides. So you're getting a much more consistent finish all the way across. And it's going to be a little tighter in the middle. And if I turn off my workpiece, we can see that the cusps get a little wider toward the entrance and they narrow down coming in, because it's just morphing between those two and doing the exact same amount of step over throughout the whole path. Now, a lot of you might say, well, that's great for one surface, but what if I want to do the whole thing? Well, the multi-axis toolpaths, I would do these kind of individual surfaces. You can, and let's just delete this here real quick. You can use it going across this whole thing, but typically I would suggest doing it little sections at a time. So I'm going to just do a brand new one. We'll get to our tool. We've already got the right one. And we'll pick our first edge and we'll say it's this one this time. And we'll say the second one's this one. But then all of our drive surfaces would have to be what's in between. Now I'll do the same 30,000 step over, and we'll set it to 3-axis, and we'll compute. And actually, before we do that, we'll go back and do zigzag. So you can do this across the entirety of it. But you can see it starts falling apart kind of in the middle. And you'll see that here in the simulation a little bit. And we'll run this one a little bit quicker so we can see the final toolpath here. Just kind of fly through it real quick. But you can see because of the difference between the first edge and the second edge, we're going to be left with some odd cusps throughout the middle. So that's where I would say what you really want to do, and just ignore those, that's because the rapid is a little low. What you would want to do in this case is you would actually make multiple multi-axis features. But if you're doing this with a planer, let's go ahead and disable this one real quick and hide it. I'll reselect geometry and I'll do it properly. I'll pick the whole thing. And then I'll compute. However, what it's going to do is go across the entire thing. Now, some of you may or may not know, but when you're in the 3-axis Pro toolpaths, under the parameters, you do have a top and bottom of job. So if I tell it the top of job is I just pick the top, and then I'll just subtract 10 thou from that, so I'll say 240, and compute. It puts the tool directly below that, but it's following the whole path. It's still not going to be doing great up and down the walls, but there is a path that might do this pretty quickly that if you have the premium, you're going to have access to. And that one is under the mill 3-axis. I'll do the same thing. I'll select my geometry. Because planers that step over as it goes down those walls, it's going to be leaving a lot of material. Well, if you do have the premium, you have the option of using this toolpath called Steep Shallow. Steep Shallow is a combination of either planar and equidistant or planar and Z-level finish. So I'm going to use the same tool. We're going to do pattern, we'll do Z-level and planar. And we'll say we'll just split it at 45 degrees and see where we go. Planar lace angle, we'll just leave it 0 for now. And let's say depth of cut is 30. And the shallow area, we'll do step over of 30. You don't get a lot of options with this toolpath. You do get some lead-ins, your boundary options, cutting extents, but you'll notice that some of this is a little less than if you did a advanced planar with the advanced Z-level or an advanced planar and an equidistant. It's because this is made to just calculate really quickly. So I don't really need the rest of these. I'm going to just hit compute. But I'm still going to run into the same thing with the working on the top of the model. It's retracting all over the place. So let's actually drop that down a little bit. Top of job. Compute. So you can do it with this steep shallow if you want just something really quick. And I'll show you what it would do before we move on to the next model we were going to take a look at. And we could always come back to this one if we have time to do the multi-axis across the whole thing. So that's our advanced rough. Now it's doing the Z-level and the planar. So it's kind of doing a mix between the two, but it is enough where you can quickly finish something where you're using the strengths of those toolpaths properly. And it's a lot quicker than setting up a multi-axis toolpath. You'll notice I still get some pretty bad cusps every now and then here and there. And we might as well just do the multi-axis on this. So if I were to use the multi-axis toolpaths on this particular model, we'll just delete this one. What you want to do is you want to set it up for different sections. So for instance, I might want to have mill multi-axis, we'll do surface-based, and we'll do morph between two curves. And actually, let's do parallel to multiple curves. Parallel to multiple curves is really good for doing walls. We'll just go ahead and use the same tool. And my edge curve, we'll just say is this one right there. But the difference this time will be the drive surface will be the top and bottom here. Now we'll tell it to do zigzag just to eliminate any of the retracts. We'll tell it it's a 30 thou step down, and it's 3-axis. So that's just doing this little section. Well, then I would need to do another one. So I can copy this one, paste it. And then my next set of geometries, I'd have my drive surface, and you can expand all this and add it through the CAM tree as well. You don't have to go through the actual wizard. I'll tell it I want to do this floor. Then my edge curves. Oh, I don't want to use the parallel to multiple surface for that. What am I doing? Reselect. We want to do it for the opposite wall. Then our edge curve is going to be this floor. So now we're getting the same toolpath on both sides. And then I would essentially do 3 of the morph between 2 curves in the middle. And the reason I say 3, we'll just blank those. And we'll do another mill multi-axis. It's because each of those little sections has quite a different pair of curves. So if you have 2 very different drive curves like this one and this one, you want to do them in their individual sections. It does make life a lot easier, and you will get a cleaner finish. And we'll do the same thing. We'll do zigzag, 30 thou at 3-axis. If you only have 3 premium, you won't have to worry about changing your axis output format. But now I can copy this one, paste it in. I'll expand it. The next drive surface would just be the opposite side. First upper edge could be either which one. I can pick that one or the other one. Because it's a flat plane, it really won't make a difference. And then I want to make another one, so I copy that, which it's already copied. I just do paste again. Now this one, I want to do the drive surface down the middle. It's kind of the same on both sides of this radius, so I might as well get all of that. And then my first upper edge, I'll just pick one of these on the bottom. Second on the other side. And compute. Now I might even need to tighten that middle one up so that it's a little bit tighter than 30 thou. So let's right click on that and go to edit. Next. So let's say the minimum on this one is going to be 10 or 15. Let's just cut it in half. So that fills it in a little bit more. It's really just that little section in the middle that's giving it a problem. But another couple of great things about these multi-axis is you can do other things like extend your toolpath out without having to modify geometry. You can use 2D containments if you need, but they're really not necessary because you're using surfaces. You do have a lot more flexibility with them. There's a lot more power behind it. Yeah, I need to change those retracts. It's going to look like it's crashing all the time. But you can see I'm getting a much better finish now with all of those toolpaths rather than doing the planar and Z level or trying to manipulate those to make this all work. Now, if you do ever run into rapids like that are giving you a problem, the multi-axis has a lot of options for those as well. I'll change it for one of these just so y'all see where it's at, but it's under this linking tab, this link tab here. I can click retracts. And for this, I'll just tell it automatic because it knows where the model is. It'll just pop it above that. And technically, I'd want to do that for all of these so that it doesn't crash on every single one. But again, that's link, retracts, automatic. And the problem's actually in the other ones, but all right. So now we're going to take a look at a couple of the other paths. I believe it was this guy. Now this already has some stuff on there. There's an adaptive roughing toolpath just to rough it out. And then they kind of put a few examples of these toolpaths. So we have their good, this is just using the advanced planer like I was showing you. This little better toolpath with the equidistant. And then they went with a flow line on this, and I'm actually going to change that. But we'll kind of go through what each one of these look like up along this surface. So we'll start with the planer. So let's just disable. I'm going to delete the bottom one because I don't really want that one. You know what? I'll leave it back in there. Let me close this and reopen it. It won't hurt to show you all. Now, if you do have the Machine Simulation Pro and you have a model of your machine like I do, you can have that all shown right in here. These are some of our lightweight Haas models that we have. And let's slow that down a little bit. I'll zoom in where we can see what's going on. And this is that adaptive high-speed milling option with the advanced rough. And when it's coming back, it's only doing about a 15 thou retract. It's not actually on the part. Yeah, we could speed this up just a little bit there. So this is doing the planer, just going back and forth. And you can see as it gets to that wall going up, it's leaving a lot of material. And it should be doing the same thing on this other side. So planer will do it. You can get a decent cut, but it's really going to leave a lot going up these vertical walls. Now, the other one in here that they chose to use for the 3-axis Pro is this equidistant. So equidistant is essentially an even cusp height. It's trying to maintain a same step over, step down throughout the entire part. So you get more consistency. Let's just zoom into this guy. Now we've already seen the rough, so I'm just going to jump to the equidistant. We'll slow it down just a fuzz. So equidistant by default uses the bounding box area of whatever you've selected as its pattern. So you can see it's using the rectangular shape of this part to apply that toolpath, which on some models is going to be fine. And on this one, we're going to see that we're going to have these turns in all the corners, leaving you with some pretty noticeable witness lines. So this one, we can see as it goes down in these corners, it's doing the wall really well, but we're really leaving these hard lines going all the way to the center. And some of these are a little off center because of the shape of the part. It kind of twists and forms with whatever you have. So it still gives you a decent finish, but not the best you could get. Now the next one that they had on here is the flow line. So we're going to use this one first. I'm going to show you what it does. And then I'm going to throw a different one on there. So we'll skip that rough again. So flow line acts a lot like planer, because it's just going back and forth in this case. But it will give you a little better consistency going up these walls. because it doesn't have to maintain that even step over. Essentially, planar is being draped over the model and it falls where the surfaces are, where these follow the surface. The benefit of Flowline is that it is a single surface selection. So you could just pick one surface and just hit compute and it'll cut it. Makes it fairly easy to use. So it did some linking there, and that's the thing that I don't really care for about that one, but it does give you a really good, consistent finish. You could always tighten that up a little bit to get a little better. But the one I would probably use, and a lot of you may guess this, is going to be morph between two surfaces, or morph between two curves. Either which one, they're kind of the same thing. And the reason I like this one, go ahead and grab our 1/2-inch ball that they're using for this. So again, we'll pick our first and second edge, but the neat thing is I could always change the direction. If I wanted to go across instead of down, now the flow line, you could do the same thing. And I'll leave the 50 thou max and 3 axis. But I can control it, have it go this way across if I want, or if I change my drive curves, or my edges, I can go the opposite direction. Let's change that retract. I didn't realize how low they had it on this. So linking, retracts, and I'll just do automatic. Like I said, I can have it go across this part, I can go along the part, depending on which drive curves you select is going to change the direction. We've already seen the rough, so we'll just go to the morph. Now the planar and the flow line both can change directions whichever way you need to be. Flow line is going to be along X or Y or U and V or long or short, depending on which one you pick. U and V is XY, just so you guys know. But I find that either which way I go, if I go along the part like this, back and forth in X or back and forth in Y, I do get a better finish, more consistent finish with the morph between two. Really is one of my go-tos when I use the multi-axis. So that looks pretty good, even going that way. Does leave me kind of this weird marking right in the middle there. Let's turn off this machine. There's that little weird kind of transition in there. So let's change that direction. Let's see if we can improve that. So all I need to do is come over to my feature, expand it, and go to my geometry, reselect first upper edge. I want to deselect this edge. I'll pick this side. Then I'll do my second lower edge. I'll deselect this edge and pick this one. The drive surface doesn't change, so I just right-click morph between and compute. All right, so it looks like we might get kind of a similar result in there. Yeah, we don't need to see the advanced rough. So it does about what the flow line does, just gives you a couple extra little passes in there. Yeah, they're probably using a smaller ball on this one. I'm not too worried about it. This is really just to show you guys how they apply. All right. Now, did any of you guys have any questions so far on the Surface Base or the 3-Axis Pro toolpaths that we've talked about up to this point? Kind of open things up for Q&A for a couple minutes. All right, doesn't look like we have any questions, so let's go ahead and keep moving. Now, if you have the 3-Axis Premium, you're going to have access to deburring. So you can deburr with a ball mill, and in this case, we just picked one of these little sections. You can deburr with a lollipop cutter, a chamfer mill, which I'll apply a couple of these for you guys so you can see how they actually apply. You have a ball mill. What does he have there? Spiral. So it's doing a spiral to create that. And then you have this contact point control. So for those of you that have multi-axis machines where you can do tilting, that one's going to come up for you guys. So I'm actually going to just run all of these real quick. So I'm going to tell this to stop after every operation so we can kind of see what each one's doing kind of clearly here. Now, we're not going to see too much of a cut happen, but let's go ahead and tell it to stop on operation change. That's under the simulation tab, and then I'll hit run. So I'm going to tell it no to not continue. So I can see what the ball and mill did. It just did a 3-axis movement to do that little portion. Slow this down a little bit more. Then we have our lollipop cutter coming in. Now this is going to pretty much give us the same thing in this scenario. But the lollipop you can kind of do more with. You can go down the walls and so on. But it's giving us a nice little deburr. And then the chamfer mill. This is going to go right across. And then we've got our spiral. So this is going to use like the tip of the tool at first and step over and down to get your deburr. And last but not least is going to be the tilt. So this one you can change where you're contacting with the tool. So even if you had a flat end mill and you had a multi-axis machine, you could still do a deburr on the side of your flute rather than the tip of your tool. So let's take a look at adding some of these. Now I'm just going to take this model and copy it, bring it into a blank file and paste it. So we'll set up a brand new job. All right. So I'm going to pick that Haas machine we have going. Select my workpiece. Now I'm going to use my solid model as my stock. And I'll just leave the origin on the top, but the base point, we'll say it's down here. So that base point tells it to put it up in the machine. So if you have Machine Simulation Pro, this base point, you can pick the bottom of the model and it'll move that up out of the table for you. So let's take a look at the first one here. Let's do lollipop cutter. So this is going to be under the multi-axis, and you'll see it under deburr. So let's go ahead and grab a lollipop. And I'm just going to pick one of them out of the system here. That's going to be too short. Let's change that tool. Those are 1 inch, 3/4. Okay, so we're going to make our own. We're going to take one of these smaller ones and just make the protrusion a little bit bigger so it'll handle what we're doing. All right, so you get 3 tabs. Unlike the multi-axis, these are a little bit different, but they're kind of the same flow. You'll have your surface path page. So you do need to pick your part. So that's the part surfaces. Now the cool thing for this one is that you want to do edge detection. I don't want to auto detect. I want to do user defined. So if I click user defined edges, I can pick the whole model and then just deselect everything underneath that I don't want. And it's really just going to do those edges inside, which didn't quite get what I wanted. So let's just do it this way. We're going to go through and do loop selections. So when you do loop selection, it does pick a loop that you're going around. So you have to define what that loop is. So you right click on an edge, hit loop selection, and then you pick an edge to tell it that's the one you want to follow. And I'll just worry about some of these bigger pockets. I'm not too worried about the rest of it. And we'll do the edges going down the side. And I can't use constant Z in this case because they're all on an angle. All right, looks like I got all the ones that I wanted. Let's make sure that I got the edges on the inside here where they intersect. Which it looks like I do. Hopefully those don't cause us a problem, but I don't think they will. And then we'll also get down the side. So the lollipop cutter will let you go down the walls. So those are the edges I want to cut, and I'll just leave the 20 thou constant width. I'm not going to check any surfaces. That's for gouge checking if you need. You'll have your edge shape, inner corners, whether you trim or you make a relief, whether you lift up or you just trim that section out. Number of cuts along edges, we'll just do 1. We don't need to extend or overlap. Tool axis control, we're going to tell it 3-axis. And then linking, we're just going to leave it automatic. Yes, Brian, you're correct. The Lollipop will let you deburr the underside if you have the room and the length, even if you're just on 3-axis. So that looks good. That kind of looks like I want it. So let's take a look at that in simulation. Oh, no problem, Brian. And Ronald, yes, we will get to the chamfer mill. We're going to change it up for another operation here. Now it is going to do those 2 holes on either end because of the way the surfaces were selected. I didn't omit those, but I didn't feel like picking all the ones all the way around. We only have so much time in the day for these events, so didn't want to waste any time on that stuff. And it is doing that edge where there's kind of the turn going from the taper to the flat. We could have deselected, but I didn't notice it. And if I was to deburr kind of that bottom edge, I should be able to add that to this. So we'll give it a shot just so we can try it, just to verify for you. But yes, you should be able to deburr kind of that bottom edge. All right. And the only reason that tool was turning red, just so you guys know, if you caught that, is because it's inside of the machine when it went down there. I would need to lift this up. It's not sitting on a fixture or anything, but we have a nice consistent little chamfer all the way through. Looks pretty good. But what if I wanted to add that bottom edge? We'll just go into our deburr, right-click my user-defined edges, reselect, and I can actually just right-click this edge and do constant Z, and it picks all of that bottom. It should be able to do it no problem. It is going a lot lower than where the machine's at, where the tool is. So what I'll do is I'll go and edit this, and I'll make the Z like 4 inches. That'll shift my part up an inch and a half. Oh, I should hit OK here. All right, that reloaded properly and it moved it up. So we'll kind of speed through this one. But I should be able to see a nice little deburr on the bottom all the way around. Now you can only do that with a lollipop. So if you're trying to do any of like the bottom edges like that, it probably will not calculate with a tool that's not going to be able to create that. We've run into that a couple times where people have tried to do corner breaks that weren't quite possible with the tools they were trying to use, so it just didn't do anything. So keep that in mind. If it doesn't calculate anything, there may be a reason why. Now I'm going to just disable that one and hide it. So let's take a look at maybe doing the chamfer tool. That's probably the most other common that we would see. Now, if you're not in version 35, we did add deburring in 34. However, you don't have access to chamfer mills. So if you're trying to use a chamfer mill for deburr, you'll need to upgrade to 35. So deburring. Now, as far as designing a chamfer mill, there's really not much to it. It just depends on what type of tool you're using, whether it's a flat bottom tool, whether it's a sharp tool. We can have all the different variations. If I add a tool to the chamfer mill category, I'll just say it's a 1/4 inch 90. So 1/4 inch diameter, angle 90, small diameter, I'll just say it's 0. I won't put a small diameter on it. I'll make it a sharp tool. If you have a flat, you'll have to figure out what that is and define it so that we can offset the tool properly. But other than that, that's really it. So I'll hit OK. So I've got my 90-degree 1/4 inch tool. Next. Now, if you're not aware and you're new to 35, let me go back a page. If I made that tool and then I realized, it did have a flat, maybe it only has about 10, 25 thou, you can go to Modify Tool from this dropdown and change that here. And you will see it change in the small diameter on the tool. And that changes it for all the operations using the same tool. So anytime you're doing the deburr, you want to pick everything, just like you do with 3-axis. Now there is an auto detect. But I typically never use it. I haven't had a lot of success with it. It's always been easier to use the user defined. And I don't think this advanced section really, because I don't have any actual edges on the model, I can't really use this. So we'll do our user defined. Actually, check surfaces for clamps or anything, okay. And then your clearance for those. But we just need user defined edges. So we'll only be able to get the edges that we can actually use. So I'll just click around. Actually, you know what? I'm going to show you guys kind of an easy way to do this that should be quick. So in 34, we added a selections portion. Now I should be able to go in and extract all these edges to another layer. My goodness, I am not. There we go. That way I can pick my 2 surfaces there, including that. Now I have a really easy way to delete everything I don't need. So all this stuff in the middle, this ring here that we don't need to put a chamfer on, these lines down the middle there, and I'll just kind of delete as I go. All right, so there's my selection. Now, if I select all this, I can actually save that selection. I'll go ahead and rename it. Edges. Cancel. So now I'll go back to my cam tree. We'll go deburr again. Mill multi-axis. Deburring. Chamfer mill. Oh, and you should be able to see if you're in the tool crib, just so you're aware, and most of you probably already know this already, if you've defined it with any flat or anything, you should be able to see it on here if you've changed it. So if your tool doesn't look right here, there's probably something wrong with its definition. If you do run into problems with that, just give us a call. We can help you out with the way they're defined. All right, so let's do that again. I'll pick all my part. And now for my auto or user-defined edges, I can just pick my saved selection. That should be able to give me all of them. Tool axis controller says 3 and compute. Yeah, the addition of using the chamfer tool this year with that is probably one of the biggest things. I was actually at a shop maybe a month before we added that, and they would have absolutely needed it to use deburr for what they were doing. So that actually looks pretty good. Let's go ahead and look at that simulation. What? All right, I'm probably going to crash. I don't know what that's about. I might have run out of resources with the meeting and everything, so bear with me. This GoToWebinar can really use a lot of resources on our system. All right. So we will create that all real quick again. Shouldn't take but a moment. I'll start with the saved selections. I'll add my layer for my edges. And we'll go ahead and create those. So I'll do create 2D, extract edges. And actually, you know what? Let's even just do it the proper way. We will go into select mode. You know what? We'll do it through the CAM tree. And I'll just stick to the BC3X mill for now. We'll just kind of speed that up to catch back up. And if any of you guys have any questions while I'm jumping through this real fast, let me know. Origins on the top, and we'll set our Z to like 4 inches. Multi-axis deburr. Now, if you define a tool in the crib, it should still be in there even if you do crash. So keep that in mind. It didn't take my change because that wasn't there, but I can still modify that. Double check that actually changed. Yeah, now I can see it's flat. All right, so we'll pick our part. User defined, advanced, not advanced, I'm sorry, user defined. Now, if you want to save selections while you're in, say you're testing stuff out, you just want to pick everything, you don't know if this is going to work out. As I'm selecting, I can go in and save those selections. So I kind of did like I did before. We'll pick half of this, most of it. I won't worry about all the little holes. Yeah, see, some of these loops are going to give me problems. That deselected some of what I had. So it may be easier for some of you to do the extract edges. I just want to verify that this will take it. Sometimes the loop will take a different loop. So if there are multiple ways that it could go, it's almost better off to select. So you don't have to worry about that headache. Like here, I would actually just want to pick these edges. It'll save me a lot of time because it might deselect a lot of stuff that I had, which you guys already just saw. Now, if you do not have a 3D mouse, I definitely recommend it for stuff like this. It does help to be able to move around as you're selecting. That's how I'm kind of moving and selecting at the same time. Definitely highly recommended for multi-axis. All right, so I've got everything selected. Now I can hit save. And if I mess up or I need to do this again, I already have that saved selection. I don't have to go through all that again. So I'll hit OK. Tool axis control will say 3 and compute. And while that computes, we've got, So Brian's asking about the tools a little bit. If there's a location where the tool crib is saved, where you can share that file with other computers for updates, they have multiple seats. So there are no master parameters, so you can't just save like one master file and then everybody all have access to it. The tool crib, however, is essentially per job. So if you want to save a crib for a particular job, you can throw that on a network drive and any computer can grab that and load it for a job that they might need it. Really, that's the way to use it. The tool library is unique to each computer, but you can have a master library that you add tools, you save that library somewhere, and then people back it up. But that's really the only way you could do it. So that calculated fairly quick, much faster than I thought it would for answering that question. I hope that answered your question there, Brian. So we'll make sure I can run simulation this time. Okay. I must have run out of resources last time, so I apologize for that crash, but it does happen, as you guys probably know. And we'll run the work piece. And like I said, again, if you guys are on version 34 and you're trying to use debur, you cannot use a chamfer mill. That is only for version 35. Yeah, the only thing else that I might want to add to this is maybe that inner circle, but all of that looks pretty decent. This is really the only way you can get that chamfer mill to run this. Now, we have run into some situations where using the chamfer mill, it would not apply geometry. Like I said earlier, it's because of the way that the geometry is shaped. It might not have a contact point. So keep that in mind. If you're using a chamfer mill and it's failing to find a contact point, you're probably not going to get tool paths. But I think we're going to open up things for Q&A. I'm going to step away for just a moment, and I will come back and we'll field any questions you guys might have. All right, so it doesn't look like we have any questions yet, so I'm just going to kind of continue some stuff here. I know I briefly talked about the steep, shallow toolpath. Might as well touch on that one again, kind of clarify a little bit more of what that is and what you're actually getting. So I'm just going to make something simple here. I'm going to just do a cube with a sphere on top of it. I think I normally go about 1 1/4, bring that up to about 1 inch, and we'll add those together. And for any of you guys that have been part of the 3-axis events before, especially if I've hosted or Mike, you've probably seen this kind of thing before. So John asked, can the default directory and file type be saved? Unfortunately, no. So the default directory, that's actually just where you saved a file last. That's a Windows thing. We just utilize that. But you can't default the type to step files. It's always going to default to BobCAD files. But that's a good suggestion for any kind of configuration that we might do in the future, and I'll definitely make note of that. Let me jot that down right now. And before we're done, I will show you where you could actually put in any feature requests, and any one of you guys that are in here. So if you do run into something that you'd like to see in the software, or if you think could work differently or better, you could let us know. We do have a spot on our website. It's always a little bit stronger coming from a customer rather than directly from us. So we always encourage the users to put those in, and we can pass them along. All right. So we'll set our origin on the top, and I'll just put my base point at the bottom, just so we don't get any collisions in simulation. So earlier, we looked at that steep shallow. So I'm going to do an advanced rough real fast on this. So we're going to do a couple of different 3-axis features. And like I said, we'll just do this as an advanced rough. I'm not going to do anything crazy. Nothing too fancy. Maybe leave a little bit of a radius on the 1/2 inch so it doesn't look too terrible. And we'll leave a little bit more allowance, maybe 50 thou. We'll make sure that we machine flatlands and compute. All right, so there's my rough. Let's just blank that out. So as I said earlier, there's the steep shallow. So what the steep shallow is, as I said, it was a combination of 2 sets of toolpaths, but it's pretty minimal. But it's made for fast calculation. So I'm going to pick that steep shallow, and we'll just say we're using a 1/4 inch ball. So I'm going to do Z-level planar. We'll start with that setup first, and we'll split it at 45 degrees. Lace angle will set the 0. Zeros back and forth in X for anybody that is not unaware, or if anybody's unaware of that fact. We'll start from the top, and then you have cut direction. So you can set an independent cut direction. So for instance, I could say for the steep region, I do more of a zig, but on the shallow region, I do a zigzag. You can play with these a little bit. There is the sharp corner, the corner option. So if you need to round a corner, or if you need to make sharp corners. And we'll go with 30 thou depth on both. And we'll just leave the vertical tangent lead. Really not doing too much here. I'm going to leave extents. We don't have any boundaries. I'm going to leave it follow for linking. Gouge check, advanced feed rates, and MDI we don't need. Now when I hit compute, it's already done. So I'm going to do the same thing with an advanced planar and Z-level finish to do the same effect. So in order to do that, you do get more control. So select geometry. But when I get to my strategy, now I need to do it as a advanced planar and a Z-level finish. And I could change which one's happening when, but that's the method I'm going to do. Using the same tool, I'll do the same lace angle. It's doing zigzag. We'll do 30 thou, step over. But the way to get this to kind of do the same thing as the steep shallow is this options. So I tell it to go between 0 and 45 since this is the planar. And I don't need the rest. I'm using the same tool. And I'm going to start from the top, zig. We'll do 30 thou depth. At angle range, we'll do the opposite. So I'll say 45 to 90. The big difference, though, is the time it takes to compute this one. This one takes a little bit longer typically, which my computer did that pretty quickly. And I'll show you what each one of those look like. So you can see there's our steep shallow path. Now it's doing some things automatically that you have options for, but I didn't set any of them. For instance, on the steep section, the Z-level finish, that's using this option we have in advanced Z-level finish, where if I highlight that one, my linking, it's going right down that model. So it's doing that real hard line. I can do the same thing, but I have to go in and tell it the linking position shifts, say 100 thousandths per depth. So now that link is actually adjusted, but I can't adjust this one. I can only adjust this one. So even though it's a really fast, easy toolpath, you get a lot more flexibility of separating them out. So this is the steep shallow. Oh, this is the advanced rough. We'll skip this. We all know what that's going to do, hopefully. And then we'll run the steep shallow. So it's starting with that Z-level finish going down the wall. And the steep shallow is a little more optimized for linking because it's not two separate operations, it's one. Now it's doing the shallow stuff. Now it's doing that region and not jumping over because it's set to regions. It does that kind of automatically. The other planar should do the same thing. And again, if anybody has any questions as we're going through this, by all means, please ask. Just kind of touching on some of the other options you have with the premium at the moment. This is really the only other toolpath that you get special with the premium, besides those surface-based and the deburr. Now, I'd still probably want to add a pencil to clean up the floor, but that's pretty decent. So let's disable the steep shallow and enable the other one, and I'll restart the simulation. We'll go ahead and skip our rough. Now I have it doing the planar first, but essentially it should be doing the same thing. And that mark there, that's not really anything. That just means that it was plunging. It does apply it slightly different though. So you can see it's kind of skipped the regions a little differently. But for a really complicated model where you might have a lot of different angles, a lot of different areas you need to use that, steep shallow might be the fastest way to do it. I need to turn off that stop on operation change. but they pretty much look exactly the same. Now the other option with steep shallow is the equidistant. Kind of show you the difference there if I do that. Now we'll say independent methods, we'll do zig, and we'll keep the same thing, zig and zigzag. I don't think we should need anything else here. And compute. So equidistant, you can see it's handling the floor a lot differently. It's an equidistant and Z-level finish. So the equidistant is doing this radial section a little differently than the way planar did. Where you could do the same thing, you just replace the Z-level with equidistant, angle ranges, whole nine. Essentially, this should be very similar, just slightly different cut pattern. Now the equidistance, like I said, taking that bounding box of the area, so it's applying that rectangular path throughout the whole process. It's going to jump around a little bit differently because of the way that it applies. The other thing I will point out is equidistant is all line segments. There are no arc moves. So keep that in mind. You're going to get a lot more code with this. So if anybody has limited memory, you don't have a lot of different ways to mitigate that unless you're drip feeding. And I think I like the equidistant on this one better, except I like the planar on the floor. The way the equidistant does the floor, I'm not a huge fan of, but it is applying it pretty nicely. I like it going across the boss, though. It works really well, kind of blends the two together since it's doing the spiral down into the vertical. So you get a much better cut pattern with this. Scott, are you referring to the sphere here? Okay. So Scott is asking, how would you do the radius on top of the floor with the premium toolpath? Well, the steep shallow is one of the premium, so that is one option. But if you're referring to the multi-axis, which I'm assuming you are, we'll take a look at that. So you can do, let's see, you could probably do parallel to multiple curves. I don't think I've ever actually tried to apply this on that sphere, so let's try it. So I'll pick my edge curve as the bottom, and then my drive surface is the sphere. Tool axis control, we'll say 3. We'll go back. Maybe we can even do a spiral. Actually, let's keep it simple first. Keep it real simple first. So that did it perfectly. Let's go ahead and edit that. I'll change that zigzag to spiral. Now, if you're running a multi-axis toolpath and you're really not sure what it's going to do, keep it simple first. Very minimal changes to the toolpath options. If you have multi-axis and you're just using on a 3-axis machine, make sure you set your output format, what you're selecting, but that's typically it. I usually stop at that selection and then compute. Then if I need to change something like a retract, the pattern, I then go back and do it. Because if you change too much at once, you don't know what might have made the changes that are affecting you. Now I can also see if I hit the shading on my model, it's actually going down into that that floor. Now, the first instinct a lot of people would have is to use the gouge check, and that's more than likely not what you're going to want to use. You have this area section. Right now it's set full of void cuts at exact edges, but if I say start and end at exact surface edges, we also have this additional margin. And this may or may not work vertically. I know this works axially, or I know it works axially. I don't know if it works radially, so we're going to try it. Yep, and that took it away from cutting into the floor. So that looks good. It's cutting it right, so I'll edit that again. And this is where I would then go in and tighten up my step over, if I want like a 25 thou minimum or maximum, I should say. And then you have things like flatlands that can finish the floor on the 3-axis side. So, in this 3-axis feature, I could technically have this toolpath finish the floor, but I'd have to get rid of the bottom allowance. So I could go in and add a flatlands to this. And I'll just say it's a 1/2-inch flat tool. And I'll stay away from the side. Let's say, what do I have? An 1/8 inch? Well, let's say it's 62.5. So I'll compute that. So that gives me the flatlands on top of everything else. I've disabled everything, so we should be good. Now, these are going to be out of order. Maybe I want to do the flatlands at the end. This is something that a lot of people are not used to yet, but now that's handled under the operations tab. So if I look at my milling job here, these are my operations that I have. Now it is showing the ones that I have disabled. There is an option. Oh, that's for the patterns. There is an option to not show those. I just don't remember off the top of my head. Anyways, so I can see my flatlands here, and there's my parallel to multiple curves. And you can see if I click on them, they highlight. So you can kind of see what operation's what as you click through. I just want to take the flatlands and move it all the way down. So it's going to do the rough, then the parallel, then the flat. Just because you have tools in a specific order in the CAM tree, that does not necessarily mean that is the order they're going to post them. Yeah, using the multi-axis, you're always going to get that best finish quality because you're going to have that most control. 3-axis Pro is really powerful and handles most models I've run into really well. Sometimes you have to finagle it a little bit, but the premium really do shine a little bit above, especially if you're doing a lot more organic shapes, variable radiuses, things like that. Now, if I really need to, I can make sure that stays off the floor by adding the gouge check. So if it did go into it a little bit, then I could use that. But you really want to use the other tools available to you before you even try the gouge check. And the reason why is essentially gouge check happens at the end. So it can really throw a lot off on your toolpath, depending on what you have set. So hopefully that lines up where they evenly kind of connect, but if not, it's just kind of playing around with those tolerances stuff. I'd probably need to add a pencil still, or just have it go further and do a gouge check and see how that does. If I come back into this feature, let's say it didn't do the floor as much as I wanted. I'll do let's keep it on this. We'll just get rid of the margin. and I'll compute just to make sure it's going to do what I want. Because again, you want to make sure you change anything first before you go too crazy. So I can see that's cutting now into the bottom, which I want. And if I add gouge check now, I can turn a gouge check on, tell it to retract the tool off of the check surfaces, which is going to be the floor. So I need to have my shading turned on, and then I'll pick the floor. And I just hit the S key to toggle the shading on and off. So that shouldn't be into the floor. Looks pretty good. We'll see how this simulates. And I'll run it kind of quicker. And again, if any of you guys have any questions or anything, we're going to be here for probably another 20 minutes or so. Skip ahead. Yeah, I would probably just, well, I know what it is. I need to have the tool a little further away on the flatlands. That side allowance probably needs to be like, to really get it, it would probably need to be about an 1/8 inch. To get that full radius on there. Just had to go in a little too far. But like I said, we'll be here for questions for another 20 minutes or so. If anybody has any other questions, just let me know. Other than that, that pretty much does it for the day. So if nobody has any questions, thank you guys for coming. We're going to be sending out a survey at the end, but and John, what you're trying to engrave some text, just flat text, or? But not over a radius or anything, just flat geometry. No problem, Brian. Thank you for coming. All right, cool, John. So I'll just use this part to kind of do that. Let's hide our toolpath here. And I'm going to leave this shading turned off. Engraving really is very simple. You can add your text. If you use BobCAD font, I usually use Helv. It's really clean. It's a really nice font. Just type out what I want, and I'll just place it somewhere on my part here and hit OK. Now, if I'm using the 2-axis, it doesn't really, I don't need to do anything special. 2-axis engrave, it's just a mill 2-axis feature. You select your text. You'll have your top of feature, which in this case is the floor of this piece. And then the total depth, I'll just say, 25,000 so we can see it. And it's just 2D engrave. And whatever tool you're going to use, you have tapered, V-tool, in-mill rough, in-mill finish. I'll just grab a V-tool. I usually go with the eighth inch 90 degree. And there's really nothing to set. I mean, you have parameters just to remind you of your depth. You have your machining sequence telling it to go from one letter to the next, and advanced feed rates and MDI. And that's it. So Mark, I'll come back to you in just a second. And we'll just jump to the engraving. Oh, thank you, Frank. Thank you for joining us. Now, obviously, the tool is too short, crashes through this, but you can see the engrave here. I went a little big, 25,000, quite deep for an engrave, but helps to be able to see it. Now, I will say, John, if you're engraving on something that's radiused and you need it on like a solid, There's actually a really cool trick that I use. I'm going to delete this. Let's say you have to do it through 3-axis, like it's on a curve. Let's just add a 3-axis feature here. There's a type of path under 3-axis. That's the project curve path. And Mark, to kind of come back to what you were saying, the different strategies in here, and I'm not sure exactly how to phrase what you're asking, but when you're looking at the machining strategies, these first ones at the top, Z-level rough, Z-level finish, planar, spiral, radial, and at the middle here, 3-axis plunge rough, those are all your standard 3-axis. That we don't even really show those, we don't even bother with those really. The pro ones start with the advanced rough, flatlands, equidistant, pencil, advanced planar, project curves, and advanced Z-level finish. The only one in this list that is not under pro is the steep shallow. That one only comes with premium. Now the other ones that come with premium are going to be your mill multi-axis surface-based toolpaths and your deburring. But if you need to if you need to engrave over, like, say, a slight curve or radius, you can actually have your text inside of your model and use this project curves. So what this is going to do, and now you have less option, or you have more options for tools, sorry, but you don't have the option for a V tool. So I can use tapered, I can use an end mill, I'll just use a ball end mill, but you can't use a V tool. Yes, Express is your 2-axis features, drills, and planar only. You only get one 3-axis toolpath. Now with the project curves, I just picked the projection, which in this case is going to be that text, and it projects it to the surface that it's underneath. So as long as I have the text placed where I want it, it should do this no problem. The big thing though is to put in a negative allowance so that you have an actual engrave. Let's maybe do 10. You still get your options for angle range and boundaries, your linking, all that good stuff. But this one's going to just link and kind of do each one of those, which those linking I don't really like. Let's links, full retract. Now that A is broken, but that's a whole nother story. That's something I can explain another time. Same thing with the B's. That's just because it is a font. I'd have to dissolve that font or explode it and then clean it up a little bit. Some of the texts do have issues, but if you're using the 2D engrave, we actually do all that vectorization within the feature itself. So 2D engrave is the one that's important to use for those. Yeah, and if I actually, let's just do that. Utilities, explode, since we got a little bit of time. So when I explode this, I also need to do a cleanup and optimize. And even that may or may not clean anything up. And if I zoom in, you'll see a couple things like this A. The reason it didn't cut it is I have 2 little geometries right there. So I'll just delete one. So let's go into the select mode, delete that guy. But then the B's had issues because it's actually 2 lines really close to each other. So if I delete one of those on both of these, it'll give me a better consistency. So now under my cam tree, I'll expand project curves, reselect my projection. Because it is 2D geometry, I got to make sure I get it all. And then recompute, and it should give me the full text. Actually, there's a couple videos for fonts and text. What I would recommend is if you check out our YouTube channel, and really anybody that's still here, any of the live events that we've done previously are also there. So when you're on our channels, if you go to our, playlist, for the live events, you have your Rhino, SolidWorks, and BobCAD standard training events you can go back to. You could see the full playlist to see uh, previous recordings. Any of the 2D CAD and CAM, John, I would check out. They probably have much more on engraving and actually bringing text in and stuff, especially Bob Art. They might have a little bit of that in there. But there's also a video that I personally did in adding your own fonts if you want, and then using them. And that's actually a little bit different. Those are at the videos section. And it's going to be a little ways down because it's been a couple years since I made these. But you will see a few videos with this background. They're really short, 2-3 minute videos explaining a couple important things of the software, open pocketing, setting your machine setup, fitting text to curves. So this would actually be placing text. I would definitely recommend that one. Align, customizing your user interface, and adding new fonts. So if you even needed to add a font that maybe a customer wants you to use, you can add those Windows fonts as well. But the fit text to curve would actually touch on all of the typing out your text and actually using the fit text to curve function. Well, Mark, we do have some on our main site, our support site, but we just found out that a lot of those have not been updated, so I'm getting to the bottom of that to make sure they do. So we do have them in other places. But yeah, YouTube's not going anywhere. No problem. Thank you guys for showing up. And if any of you guys have any more questions, I'll be here for another 10 minutes or so. Again, thank you guys for joining us. If you don't have any questions, we'll be sending out a survey here in a little while afterwards. Always like to hear some feedback. So if you guys have any suggestions on things you would like to see, let us know. We also have our Launchpad. Now, actually, Mark, if you go back a couple weeks in that YouTube channel of the previously recorded ones, you will actually see that. We did one a couple weeks ago just on CAD and CAM. This one from 8 months ago on 34, but we've done a lot of those that would just be Express. It doesn't cover the entirety of Express because we're not using Planer, but Planer is part of that. Another thing that I want to share with everybody here, if you don't already know about it, we have launched, typically no, it's not described as Express. It'd be 2-axis mill, which is essentially Express, but Express also adds Planer. So this year, or last year actually, late last year, we launched Launchpad. If any of you don't know about this, we have some free courses, which if you're brand new to BobCAD, I definitely recommend the Getting Started video series. It goes through some basics, basic 2D part, wire EDM, lathe, mill. It touches on a lot of the basics. But we also have our subscription bundles. And in those, we actually have courses. So with these courses, you'll have your mill fundamental courses, which I believe we have 10 or so of those. We have our mill turn, which we just got finished with, 2-axis lathes, which that has 5. So we have quite a few here, and it is a subscription. So we're actually adding more of these, and we're going to be adding more defined eventually. We're right now focusing on a wide spectrum of how to just use the module, and then we'll get into more specified details later on. No problem, Mark. Thank you for coming along. All right, looks like a lot of you guys are jumping out now. I'm going to keep this open for about another 5 minutes if any of you have any other questions for me. If not, again, thank you guys for coming. Yeah, sure, John. I could show you the text again. So let me back that up. All right, there we go. So I don't have any text on the screen. I'll go ahead and delete that toolpath, and we'll just do it as the two-axis engrave. So under Create 2D, right in the middle, you'll have your text function. So I do recommend BobCAD's HELV text. I find that to be one of the cleanest, nicest. I'll just type out BobCAD here. Now I could change the size of it, make it like 250. Move this little ball around if I need to move it somewhere, and click where I want it. So I'll hit OK, and then cancel. Now, as far as two-axis engrave, if that's all you're doing, you would just go to Machine Setup, middle two-axis, and then when you select geometry, you're just picking that text. We handle all the vectorization in the background. Now, you do need to make sure, like especially in this case, my top of feature is actually below the top of stock, so I need to make sure I define that. And then I'll tell it like a 10,000 depth. Actually, let's do 5. So I want 2D engrave. Next. You can't use tabs or anything on these. You wouldn't need the posting page for this. And I've already got that 1/8 inch 90 degree in here, so I'll just stay with that. It's going to tell you what your total depth is again. You do have your machining sequence that you can change, but I usually just leave it on closest for this. You'll have advanced feed rates and MDI, but we don't need to use those currently. And then that gives you your engrave there. And again, I didn't make the tool long enough, so it's going to look really, really bad on that sphere, but that's all right. And there's my engrave. No problem, John. Thanks for coming. All right. Well, I think that's going to wrap it up for today. Thank you guys for joining us. And until next time.